In this video, we're going to deploy our final project to the board. So this final lab project. I have already done some changes on the hex decoder. I will explain which changes it is. If you remember how we designed the hex decoder, we anticipate it as active logic. It will activate the display. But so this is how we drive this equation based on this came up when all are ones. But the manual of the board that we are using, we can see that the board is applied a low logic level to a segment will light up. So it means that when it's 0, it will light up, for example, A, B, C when it's 0. When it's 1, it will be off. But on our design, it is active high. So that's why I have inverted the ABC to G to a hex that is invert of this one, and I apply it on our hex decoder so that we can display the invert of that one, so it will be the same. So this is just simple modification, so we have fixed that problem. So if we go to the pin planner, you can see that all of the pins, for example, for A, if we go to the board now and look at you can see there you have A. So 0 it's A until 6, so that is A, B to G. So I have give the pins name accordingly here. So this is how you should do it too. And then you can see for the switches, which are from X and Y, if you go to the switches, here are switches. So X, I have given switch 0 to 3 and Y from 4 to 7. So and those pins are here too for X, from X0 to X3, which is X1 to X4, and from Y1 to Y4, 0 to 3. And then the sum, I have displayed them on the LED light, so we can look the binary of that too. And then that if you go to the LEDs, so from sum 0 to sum 3, which is 1 to 4 bits, I have give the sum 0 this one to sum 4 this one too, sum 3. So from sum 0 to sum 3, they have this pin name. And the other thing that I've given the names of the two are select and control. So control is our subtraction. So if you want to subtract or plus addition, I have given them this is pin AD10. So if you go to the switches, you can see AD10, this switch here, I have given to the control. So when it is low, we are doing addition, and when it's high, we are doing subtraction. And the last pin here, I have given to select AE12. So this pin here, it's for selecting between the two models, which is structural or behavioral. So we can go to the pin here, we can see select AE12. That is the selection of the model, which is our module here. So when select is 0, we are selecting structural, and when it's 0, we are selecting behavioral. So that's how we have done the pin planner, and then we have two more LED lights, that is carry out and overflow. And if you go to the pin planner again, you can see carry out have been given to LED light W21. And if you go to the manual here, and then you find W21, the LED light 8, it is for carry out, and overflow I'll give it Y21. So if you go to the pin planner and you find the overflow bit, you can see it's Y21. So that is how you should do it if you want to implement this too. So now we can go and compile all of this, and then we can start to testing on the board. So if you compile it, so our design is already full compiled. And one thing to remember on the hex Verilog file, you should remember to change. I've did some typo here. It was 21. It should be S2, not S1. So that one I've even shown that video previously. So you should fix it, that error too. So because on the here it's supposed to be is S2, not S1. It should be S2 too. So now let us deploy this on the board. So you can see here I've already selected my file, and then if I press start, I'm gonna deploy this to the board. So let's go to the board and check it how it works. So here we are at the board. So let us press start here again. You can see that our board is uploading the program. So now let us test this functionality of the code as we did on the model sim. So let's assume that we are using unsigned numbers. So if we are using unsigned numbers now, so we know that from here, this is S0, which is switch 0 for X, to this switch here, which is switch 3. So this is 4 bits indicating of the X value, as we have done it on pin planner. And we have from switch 4 to switch 7, these are Y, 4 bits, both of them. X are 4 bits and Y are 4 bits. And we have this switch here, switch 8, this one is for controlling addition or subtraction. When it's 0, down it is 0. So when it's 0, it is addition, and when it's up, which is high, 1, it is subtraction. And the last switch here, switch 9, this is for selecting between those two models, between structural and behavioral. Now, if we test adding from 0, so if I switch this, the first switch here, 1, so it is 1, X is 1, and Y is 0. So this means that it is 1 plus 0, which is 1. We can see even this LED light here, which is, we have LED light from LED light 0 to LED light 3, this will show the answer of this one. So this is in binary and this is hex. These two are same thing, but one and shows displays on the hex and one it is in binary. So now it is 0, it is 1, x is 1 plus y is 0, so we have 1. So if we plus from 1 plus 0 is 1, and then 2 plus 0 is 2, because I'm not touching the y value, and then we have 3, and then we have 4, we can see even the binary is showing 4, and then we have 5, 6, 7, 8, 9, 10. You can see now hex 10 it is A, and then we have 11 B, and we have 12 which is C, and we have 13 which is D, and we have 14 is E, and last is 15 which is F. We can see that all our LED lights light up and we have F. So since this is 4-bit summation subtraction, if now we turn, so we have 15 plus y, it is so x is 15 and y is 0. So if I turn this one up here, so it is, so if I flip this one here, we see that we have 0, but our overflow bit is on, because 15 plus 1 it's 16. Since we only is 4 bits, indicate that we have an overflow and a carry out. We have a carry out. That is why this LED light it is on. So 15 plus 1 it is 16, that we have a carry out bit here. Now because this is unsigned number, so if we take, for example, 3 plus 2, so we see we have 5, but if I starting flipping this switch here, it should be 3 minus 2, which is 1. So if I flip the switch here now for subtraction, so we have 3 bit, because this 2 is our own 3 minus 2. That is why it is 1. So this is unsigned. Now if we starting to look at it as unsigned, as sign, so we have 2 complement sign number. So if we take, for example, 7 plus 1. So if it was unsigned, the answer is right, but 7 plus 1 in sign number second complement, it's not right. That is why we have overflow. This one here, it indicates minus, if you read this in second complement, it is minus 8. That's why we have an overflow. We know that in second complement, the range of 4 bits that we can present the answer, it is from minus 8 to 7. And then if we, for example, if we look at the if we take an example of minus 7, so we have minus 8 plus 1, it is this is minus 7, we are using sign number, and then we plus minus 2. So minus 2 in second complement it is, so we have these 2 bits here, this 3 and this one, so that is minus 7 plus minus 2, which is minus 7 minus 2, it should be minus 9, but it shows that we have 7, and that is wrong answer. That's we have an overflow bit detection. Lastly, when we take an example of 7 plus minus 1 in sign numbers second complement, so we want to do 7, let me take all down, we want to do 7 in sign number second complement, so 7 want to do 7 plus minus 1, so plus is 0, so it's 7 plus minus 1, so y it should be minus 1, and in second complement minus 1, it is all the bits are 1, so we must do all the bits are 1, so that you say we have the answer is 6, and it's the right answer. So 7 plus minus 1, it's 6, because we don't have overflow bit, and the answer it is in the range, and it's the right answer. So now let us test the last functionality that we had, which is because we have implemented 2 models, structural and behavioral. Now, all of this time we have been using structural model. Now we want to use behavioral. So what happened if I change this from 0 to 1? Because we know this is the right answer, it should change anything, it should also represent the same answer. So you can see it is the right thing, nothing changes. So if in your model you implement and it's changed when you switch between the models, you must do something wrong in either of those models. Both answers should be the same, and they should be right answer. So now is for this video. We have covered all the things that we have done in this project of the addition and subtraction between behavioral and structural for both implementation, and we have simulated on the model sim, and we have deployed on the board.